So we'll start with the new topic today. As originally I've already given you good idea about what are the different methods on which you can compare the alternatives, and that's a very important uh, overall concept which we are going to cover in this particular course, right? But one thing that I mentioned, so far we have looked at the examples where everything was known, right? I had given you values, like I had given you the exact cash flow that is happening in each year. I had given you the duration of the project. I had given you the rate that you are going to use. Yes, there's still, it becomes quite complicated, but everything was determined, predetermined more or less, right? But the real world is not like that. In real world, you always have certain what I would say possible variability. For example, the cash flow, you cannot 100% estimate the cash flow is going to be 1100 rupees in this particular year, right? There's always some sort of a possible variation. It could be 1000, it could be 900, it could be even 1500, depending upon how the future unfolds, right? So those kind of things are an important part of decision making, because if you do not account for that kind of possible variation, sometimes that variation can be so large that your project original alternative that you selected may not longer be a good alternative, because it could be a very high risky project. The what you are using as a cash flow could be just a mean value, but the real value could be actually very high or very low. And in that case, you would still want to have some method to know whether the decisions that you have made are okay under the variability of all these potential variables that we have taken, right? So with that, I will introduce you. So of course, there's a concept of risk and uncertainty and probability that goes into it, and I will gradually move you towards taking that into account. So I will share, I think 10-15 pages from a book, just a basic overview of the kind of probability concept that we are going to use in this class. So in case you have difficulty, just read through that and let me know if you are not able to understand that, right? But we are going to keep it simple, just the concept is more important for me to use, right? But before we go into probability, I'll gradually move towards that. I'll start with something called a sensitivity analysis, right? So probability is related to the chance of something getting some variation occurring in a particular value, let's say cash flow in a year one. But sensitivity analysis is more towards whatever the reason of the variation in, for let's say in a cash flow, what will be the impact on the decision? That is something that you are interested in, right? So probability is more on what factors contribute to this variability, but the sensitivity analysis is more on the what happens because of the variation in a particular value to the project outcome or the selection of the alternative that you are interested in. Okay, so in all our preceding discussions, we had arrived at a particular decision. Whatever that was, assumption was either you are accepting, either you are rejecting, or whatever selection of alternative, by assuming that all the different variables, and by variables I mean the, for example, the cash flow in, the interest rate, the salvage value, etc., all were accurate and constant, right? We started with this assumption, but this is not the case in the real world. So it actually, the estimate of the rest of the variables, most of the time you will find that you will never have a one fixed value. It is always likely to change. That's how the complicated the real world is, because it's very hard for you to estimate the 10-year salvage value, right? How much will this product be worth 10 years from now? Nobody knows, right? Nokia whatever the 3100 mobile phone, its salvage value is much more than its original cost, because of some sort of a sentiment got attached to this, but there's no actual value for that particular material. That's completely an obsolete technology. There were a lot of similar phones similar to Nokia 3100, which if you want to sell now, they will sell only like a 1 rupee or 2 rupee kind of thing. Recently, I don't know if you guys were following, or somehow my news feed is filled with that, is one original first generation iPhone was sold at some $1 million value, right? So of course that's not the value. So it's very difficult how to estimate the salvage value of such kind of product. There will always be a variability associated with it, right? So we would want to know what will happen to our decision if such kind of variation were to occur, right? So that's what we are calling something called a sensitivity analysis, which is aimed at studying the impact of change in the value on the economic decision, right? So let me give you a conceptual diagram so that you are clear on which part of. So a lot of the probability discussion comes here, the causes and their impact on the variation in particular variable. But right now I am teaching you only this part, which is whatever the reason of variability in a particular variable is, what will be its impact on the decision that you have originally taken. Assuming that everything was constant, how does it change? That's something we are trying to do using sensitivity analysis, right? So the change in the variable values may or may not lead to reversal of the original decision, but even if a slight change in one variable leads to the reversal of the decision, we say that the variable is highly sensitive. Let's say you had certain cash flow series, whatever that cash flow series was. Now you say just only 10% change in the first year cash flow makes the calculation such that originally if your decision was to accept, now the decision is to reject the alternative. It means just the minor 10% variation or just even 5% variation is actually causing you to reverse the whole decision that you could take. So this is a variable which is highly sensitive variable, right? 10% is just an example. There's no exact definition of what a highly sensitive is, but you have to determine whether 10% is likely. You can easily say 10% variation is very commonly found in your interest rate and so on and so forth. And because of that, if your decisions are getting reversed, it means this variable is very sensitive and you need to be careful particularly about that. But let's say even if there was this cash flow were to go down by a factor of 50%, or let's say just became half. Even after becoming half, if your decision to take the original project is not changing, or even let's say originally it was 200 rupees, now it is just 50 rupees. Even after this, if the decision is not getting changed, it means your overall calculation is not sensitive to this particular variable, and therefore those variables are not as sensitive, and you can perhaps be relaxed that okay, even if this changes, nothing is happening to me, at least I have made a sound decision, right? So typically the managements end up focusing on highly sensitive variables, and that is if such variables they can dedicate more energy and efforts to estimate their value more reliably, right? If a particular variable is highly sensitive, it is natural that you would spend more time and be more rigorous in your method to estimate that, right? But I'm not 100% agreeing with this statement that you can only focus on highly sensitive. Sometimes the variables are interconnected. For example, if you do some effort to make the cash flow in series 1 or year 1 to be a particular value, it might influence how the cash flows in future subsequent years will happen, right? So if your future cash flows are not highly sensitive, then actually that presents a leeway that you can actually modify something. So you can interplay. It's still like the float kind of a you do in the project management, right? Typically you focus only on those variables which are on the critical path, but the non-critical path variable allow you to adjust the resources evenly, right? So they are not completely useless. It's just that, yeah, for project duration not to be overcoming from a particular fixed time, you should definitely focus on your critical variables, but non-critical variables are still important because they allow you the flexibility of moving in the system, right? So this is what I would also present here. But yeah, let's say that as a person of immediate interest, because our decisions are financial in nature, we would want to focus more energy on variables which are highly sensitive, right? Okay. So there can be multiple combination, and again this is just to make it more structured for you to learn, not to make things unnecessarily complicated, but I'll give you the concept introduction in a more systematic manner. So sensitivity analysis can be done for a single project in which there can be one variable at a time, there can be two variable at a time, and there can be multiple variable getting changed at a time. Everything is a possibility in a real world. Similarly, you could also use sensitivity analysis for comparison of alternatives. So there are more than one projects. In that case also, there could be one variable, there could be two variable, and there could be multiple variables, right? I'll give you examples of all of this so that the concept stays with you. But this is not, whatever the principles are applicable for one variable is as simple as applicable for multiple variables as well, right? So For example, it can be done for any type of comparison method that you are using. You would either present worth, annual cost, internal rate of return, doesn't matter. The sensitivity analysis works for everything. It can also be done for something called a pre-tax and a post-tax revenues, right? We will come to taxation later, but idea of ultimately for a business, it's very important to do the analysis after taxation, because that's the net effect you are going to get or be able to generate the profit out of the particular alternative. So this post-tax, we will discuss later how the taxation works, but you can also do an analysis on pre-tax revenues, post-tax revenues, and so on and so forth, right? And in general, it's quite useful or intuitive when you represent this sensitivity information in form of a graph, which we will call sensitivity graphs. Graphs make it easier to understand what is happening. Otherwise, numerical values sometimes become cluttered for a normal person to understand. Okay, let me show an example. So far with me, so far you're able to understand what we are trying to do. Okay, let me give you more examples. So this is the alternative for acquiring a new piece of equipment. All the cost, everything has been given to you. And this table gives you a first cost, the income, the outgoing, the salvage value, the interest rate, the service life, and this kind of formula, which I might give an exam so that you can also actually easy for you to calculate and you're not relying on calculators too much, right? So this kind of information is given to you. Let's say we are taking only one variable, right? So this is only a single alternative. So you just need to make a decision whether the NPW is greater than 0 or not greater than 0 for the given MARR which we are dealing with. This is also a MARR value, right? So in the base case, whatever the current information is given, the NPW of this particular alternative is coming out to be 52,869 rupees at the MARR of 12% that we have assumed. Okay. Now assume that the income value, which is to be 1 lakh rupees in the beginning, just becomes 90,000. So this is what? 10% variation, 10% less than what you had originally anticipated. If you put that into the formula, your NPW becomes minus 3,632 rupees. So your decision is reversed. Just by 10% variation in this annual income that you had, your decision is getting reversed. So it means that the annual income that you are talking about is quite a sensitive variable for this particular alternative, right? You can also represent such kind of information in graphs such as shown here. What is the graph? On the vertical axis is the present worth, because NPW in this case is, that's the metrics that we are looking at. And on the horizontal axis, you are plotting the variation, right? So here I have merged the two different variables on the same axis, but actually the variables are, the graphs are also distinct, so don't worry about that. In the first case, let's say the MARR changes from whatever the percentage rate basically changes from certain values. So when this line basically shows that at 10% MARR, this was the present worth, at 15% MARR, this was the present worth, this is where the present worth became 0, and at 25% MARR, the present worth became less than 0, right? On the other hand, this is not exactly this kind of an example, this is essentially a illustrative example. On the other hand, I have plotted the variation with respect to the number of periods n, right? So if the original n was 8 years, then of course this is the kind of present worth, but if number of period goes higher, you see there is some sort of an increment in the average present or the net present worth for this particular alternative, right? So you can plot using such kind of percentage variation. You can make multiple graphs, you can make all them combine into single graph also, I'll show you how. But essentially this helps you understand whether a particular variable is sensitive or not, right? If there is a variable which is insensitive, you are likely to have a rather flat curve, which is slope tends to 0, right? If it is a too high or a very large positive or a negative slope, it means something that you need to be worried about. Okay? Does it make sense how sensitivity is represented using graphics? This graph we have also seen before. When we are doing the IRR calculation, we also plotted NPV with the MARR percentage change. So this graph we have also seen before, right? So you can actually, with help of these graphs, you can actually estimate when exactly will your decision going to be changed. So for example, if the question is, what is the percentage MARR that you should be comfortable about? So here you should at least expect somewhere near 18%. Below and above that, your decision to choose a particular project might get reversed, right? So this is a critical variable. In this case, at least the decision is not getting reversed. Could be that if the project becomes very small, let's say just 5 years or 4 years, it could be that in that such small duration project, your decision may get reversed, right? So such kind of information you can extract using such kind curves as well. Okay, making sense? All right, let's look at one alternative but two variables. Alternative is still one, but now the variables are two, right? So in order to perform the sensitivity analysis of two variables simultaneously, for example, the income is R and the equipment life is N, we typically present this in form of, this is the generic form. We know that these are the variable, R is the variable, N is the variable. So I put my entire cash flow series in this format. Now, if you do it in Excel, you can just independently vary both R and N together to get a good range of ideas on what's happening, right? Now, but in order to show this graphically, there are two ways to show. First is something called a family of curves, and the second is something called isoquants. Okay, let me show you what is the difference between family of curves and isoquants. So family of curves is shown this way. You know that originally two variables were of your interest. You wanted to see the variation with both variables, but you are changing one at a time, keeping other one at a fixed level. So what happened is, let's say in this particular value, the N is always 5, kept at 5. Now, when the N is kept at 5, you can still change the income value and see the effect on the NPW. So this curve here represents all the variation of this alternative that comes only by changing the value of income, keeping the N constant, right? Now you can make such plots for N equals to 6, N equals to 7, N equals to 8, N equals to 9, N equals to 10. So still you can make a decision. You have just plotted multiple graphs on multiple lines on a single graph. Now depending upon where do you really set your, let's say as an investor you expect that N is going to be 7, so you are interested in this line, and based on that you can make a decision on when the reversal will happen, at what cash flow the reversal will happen, right? If you are 100% confident that N is going to be 9 no matter what I do, then your reversal is going to be on this particular cash flow. So you can use these graphs in such a manner to get still an idea of when the alternative decision to select an alternative changes. Clear? This is called family of curves because there are multiple variables. Of course, this can be done easily in only a 2D format. 3D format you can still do, but higher order it becomes really clumsy. Immediately you can see it becomes very clumsy, right? But it's called family of curves. Now, pay attention to this thing. So, let's say I draw a line at a fixed NPW. Let's say in this case 50,000. So there are multiple combinations of N and income which gives me the same NPW, right? So there is one combination which is what? 10 comma somewhere about this 11,000, let's say. Then this is the combination of 9. Oh, this is not 11, whatever the value is, this is 11. So this would be somewhere about 10.25, let's say. This particular value is 8 and about 11.5. And perhaps if you extend this, it will come somewhere about 7 and some 12.5 or something, right? So essentially, if you draw a horizontal line on family of curves, you can find multiple combinations of N and R, which are the two variables of interest, whose combination will give you the same NPW, right? Similarly, you can do it for any NPW. If you are just interested in net present worth as 0, all these values of N and R combinations will give you the same NPW, which is the 0, right? So precisely this information is represented in a format like this, which is called isoquants. I'll not explain this whole narrative, you can read it on your time, but precisely this is a combination of N and R, and when you join this line, for each of such line, the NPW is a constant value for whatever the C1, C2, C3 is. That's called an isoquant. So for a different NPW, this curve might behave differently. For NPW, let's say 50,000, or NPW at 60,000, or NPW at 0 or something, whatever, this curve you can plot, right? But the curve at NPW equals to 0 is particularly useful because any point that lies above or below this particular curve will signify there could be a change in decision, right? So then isoquants become immediately helpful. If you know a combination of N and R, you plot it with respect to the NPW 0's isoquant, and then you can make a decision whether it will result in reversal or not, reversal of your original decision or not. Making sense? Any confusion here? Sure? 100%? Alright. Then there is also a possibility, again graphically, when you are dealing with one alternative but multiple variables. Isoquants and everything is only capable of handling only 2 variables at a time. The more it becomes clumsier, so it's not as intuitive. But what you could do is, you could plot something called a spider graph. What do you do? Let's say you have variables, income is a variable, your outgoing or whatever the cost. Let's say your income is, how do we show income? I'll just write income, cost, your MARR, your N. Everything you expect some variable around it, right? So you fix a base case. Base case is that originally whatever the information was given to you, you call that as a base case information income. Now you can estimate the percentage change in income compared to the base case. Let's say originally income was 1 lakh rupees. Now in the next situation you are expecting an income of 1,10,000 rupees. So that is 10% change from the base case. If in the next scenario you are assuming an income of 90,000, that is minus 10% change from the base case, right? Getting the idea? Similarly, the cost, let's say the original cost was 50,000 in the base case. If your new cost is 60,000, so that's how much? 20% positive change. If it is 45,000, that's minus 10% change from the base case. Similarly, if your N was originally, let's say 12, and now you expect that N could be 13, it could be 1 by 12, whatever that number is coming out, positive percentage change for that, right? So the spider curve can be plotted using keeping that 0%, 0% is becomes the base case, and you expect the whatever your target variable. Here the target variable is the IRR. I am just plotting IRR as an illustrative example. It could be anything, NPW, whatever you are interested in, right? Could be anything. So at 0% or whenever in the base case, this was my IRR. Now for each of those parameters, you can change the percentage change shown on the x-axis and the corresponding change on the y-axis. So how do you represent, how do you read this particular curve? This is the sales price curve. So when the sales price increases by 10%, your IRR changes from somewhere about 22.5 to somewhere about 30%, right? Similarly, when your sales price increases to 20% compared to the original case, your IRR changes from 22.5 to 32.5, something like that. Here, if your income goes 30% below the base case, your IRR becomes minus 10% compared to the 22.5 in the base case, right? Similarly, you can plot other variables. This was only for income, this is for sales, this is for indirect cost, this is for capital, and like that. All of them has to pass through a one single point, which is by default the base case values, and accordingly you can estimate. Now, the steeper the slope of the particular curve is, the more sensitive the variable is. So in this case, if you see, X is what? Indirect cost is not very highly significant variable, not highly sensitive variable, because more or less you are having rather a flat curve. Even if you have considered minus 50% compared to the base and 50% positive compared to the base, the total variation in IRR is not very high. So it's not a as sensitive variable. But if you see the sales price, there is a huge variation, and therefore this variable is particularly sensitive for you. Making sense? This is called spider graph. This you will actually use in your project quite often to represent which are most significant variables. Sometimes you don't know, right? So actually, to do sensitivity analysis, you are assuming the 20% variation, you are assuming 30% variation, irrespective of what are the causes for it and irrespective of what is the probability that there will be a 30% variation in a particular thing. It's just about mentioning, it's just about assessing the sensitivity. If hypothetically your percentage change is about 30%, 40% compared to the base case, what will be the impact on the original decision, right? That's the only thing you are doing, irrespective of how did the variation come or what is the probability that this variation will come. With me so far? Okay? Alright. So, let me also introduce you something called a scenario analysis. You can easily imagine how many combinations you need to try out, right? In order to really assess the sensitivity, it becomes cumbersome very easily. And therefore, of course, you need to rely on tools such as Excel, even more Excel powerful tools, something called @risk. I don't know if you guys have ever gotten a training into @risk, but this is a free student software also. You can play around with it in terms of understanding how does it work. It's an Excel plugin. This is not part of the course. I'm never going to ask you @risk simulations, but quite commonly used in the industry to do such kind of simulation analysis, right? So, but at the same time, you can assume there will be so much difficulty each time you are having so much variation. Instead of that, what people also do is they come up with something called a scenario. So instead of varying each of these individual variables 10%, 15%, 20% all the time, they define something called a scenario. For example, the scenario could be a worst case scenario, a normal scenario, and a best scenario. Scenarios is nothing but simultaneous variation in all the variables that are of your interest. Instead of varying individually each of them, you define that in a worst case scenario, I am expecting that my income will be this, my outgoing will be this, my salvage value will be this, and blah, blah, blah. In the best case scenario, I'm assuming that income will be this, outgoing will be this, and so on and so forth, right? So the simultaneous variation of all the variables of your interest is called a scenario, right? So, example, the base case, we still had a normal, you can call it normal or the base case. Income is 1 lakh rupees, outgoing is some 5,000 rupees, salvage value is 50,000, interest rate and service life is given to you. You are making a worst case scenario, which is income goes below, the cost increases, the salvage value is not as good as you were expecting, the interest rates are higher and the service life is also lower. Compared to the best alternative where income is higher, costs are lower, salvage value is higher, interest rates are lesser and service life is higher, right? So this is you have defined. You could define n number of scenarios, scenario 1, 2, 3, up to 100, up to million, depending upon whether you can categorize them together. Idea is that you expect, in a particular scenario, you expect all the variables will move in such manner, right? That is something you have to define, not always given to you, right? Now, instead of doing sensitivity analysis for each of individual combination, you just do it for scenarios. So you calculate the present worth for worst case scenario, you calculate the present worth for normal scenario, and you calculate the present worth for best case scenarios, and you can make a judgment on that, whether you like this particular alternative or not. Okay? So, for example, if net worth present corresponding to worst scenario is a large negative value, right? And the net present worth corresponding to the normal and the best scenario is just a very small positive number. Let's say your NPV positive values are shown, 0 is here. For your worst case scenario, the NPV is, let's say, minus 10 million. But even for your normal, it's just 1 million, and for best, it is 2 million. Then you can make some doubt this project is likely to have more negative expectation rather than a positive expectation. But scenario analysis immediately does not give you that answer. It will just give you how it performs across different scenarios. In order to make a final judgment on this, you need probability, which I will introduce later. Okay, but the idea is you can compare, oh, this, or you can also, there can be multiple combination. It could be that your alternative 1 and alternative 2, even the best case scenario of your alternative 1 is, let's say, all I am talking about like the increasing value positive. Even the best case scenario of alternative 1 is lower than the worst case scenario of alternative 2. Right? In that case, you know that among these alternatives, alternative 2 is always going to be a preferential for you, because even if performs as bad as we are expecting, it's still better than the best case of the other one. But there can be multiple combinations. There could be in between, there could be some overlap and all, and that's where the probability comes into the picture. We'll deal with that later. Is concept clear in terms of how to do the scenario analysis? Let me show you an example. Just to give you some ideas. Again, this is superior to sensitivity analysis because instead of just expecting a random variation, you are putting some sense or some thought into understanding how the variation of different variables will occur simultaneously. So there is a this has to be more calculated. There's the intelligence of the, or the knowledge of the business goes into making the scenarios, conceptualizing the scenarios, and therefore it is more useful for you to make decisions, because this is something that you as a company are likely to face, right? So there's a lot of thought process that goes into conceptualizing the scenarios, and therefore the outcome is also more acceptable to the people in a particular organization. But again, this, how many scenarios will you conceptualize? There could be, the reality could be way too complex for you to still come up with 100 scenarios, 500 scenarios. It's not possible. Typically, when you are trying to come up with scenarios, 5, 6, 7 maximum, right? You are limited by your human intuitiveness around them. Therefore, it becomes limited. And you also need to have a huge data, right? You need to, for each scenario, you need to estimate the corresponding value of the variable that you expect will happen. For example, here, just for 3 scenarios, if your variables were 6, you need to have an estimate of all these 18 values, right? In each case, you are estimating. If the variable becomes 7, this will become 21, again multiply, keep on multiply, right? There could be 7 scenarios, 7 variable, you are dealing with 49 values that you need to estimate more precisely. So it becomes cumbersome very easily, and therefore you need computer intervention also to handle the mathematics behind it, right? But let me give you an alternative example of sensitivity analysis we are doing for 2 alternatives. Okay, your alternative 1 and alternative 2 is given, the first cost of both are given, the incomes, the outgoings, the salvage value, interest rate, and the service life I am keeping constant for both. Alright, the net present worth of alternative 1 in this, whatever this base values are we calling, is coming out to be, let's say, 52,869 rupees. The net present worth of alternative 2 is coming out to be 8,394, right? So of course 1 is more preferable to you compared to 2 at this stage. Now let us change each of these variables one by one. For example, we just consider the variation in income, right? So when you change the income of alternative 1 from 100,000 to 90,000, the net present worth changes to minus 3,663, which we already saw in the previous example. And yeah, so essentially this kind of variation you can plot in this curve, right, where your net present worth of alternative 1 and 2 is on the y-axis, horizontal axis is just one variable whatever you are considering. Alternative 1 shows this graph, alternative 2 shows this graph. So this is the line where they meet. Any income higher than this particular point will mean that alternative 1 is better than alternative 2, right? Here in this region, alternative 1 is better than alternative 2. In the region below, alternative 2 is better than alternative 1. And in the absolute here, somewhere here, both the alternatives will become useless for you in this particular case. So again, using the graphs, you can still make a very good judgment or an immediate judgment on where that decision is likely to be changed, right? This you will more likely be using in your day-to-day life. Plot all the alternatives on a single curve and immediately it becomes clear of which is going to be useful for you. Where exactly do you see this alternative coming into play versus other alternative becoming important, right? We can also assume or like different scenarios to this. So for alternative 1, I have defined the worst case, normal case and best case scenarios as the effect on income and salvage value shown here. I have also defined for alternative 2 the worst case, normal case and best case scenario effect on income and salvage value shown here in this particular table. Now all I need to do is calculate the present worth for each of these scenarios for both the alternatives and then you can make the decision, right? So all these things are already given. I'm just continuing the same example so that you can follow in the slides very carefully. So what happens is for alternative 1, worst case scenario, this value is 85,000 instead of the 1 lakh in the original one, and the salvage value is 25,000 instead of the 50,000 in the original one, right? So this comes out to be minus 39,000 something values. NPW for alternative 1 for normal scenario, this we have already calculated, 1 lakh and this is 50,000. So this comes out to be 52,869. And NPW of alternative 1 for best scenario, this value is 115,000 and this salvage value is 60,000. This comes out to be 1,40,842. I'm hoping that all of you are now fast enough for these calculations. You see how many calculations you need to do even in a simple question. Like just 3 scenarios, 3 variable, you are dealing with 9 calculations immediately. So your calculators should run fast and that's why the practice part is over now. You need to ramp up your game. If you make mistakes in each of these individual calculations, you will ultimately not get good answers, right? Concept is simple. This course requires you the practice of getting accurate results in a faster manner, right? So you need to ramp up your practice if you have not done so already. And similarly, and this is just likely be like a 4 or 5 marks question. This is not conceptually like out of 100, this will carry only such weightage, right? So really, you need to start doing calculations a lot more rigorously if you're not doing. Alternative 2, worst case, the salvage value here was 60,000 and the income was 60,000 and the salvage value was 20,000. So immediately you do this calculation, it will come out to be minus 111. Alternative 2 for normal, alternative 2 for best. So just based on these 3 values, I'll maybe summarize it for you. Worst, normal and best. For alternative 1, the value is what? Minus 39, 53, 140. For alternative 2, minus 111, 8,000 and 68. Just based on this info, which one are you likely to choose? Yeah, more assuming that the worst case and normal and the best case probability for each of these alternatives are equal, you can likely to say that yeah, this particular alternative 1 is better than alternative 2 because individually in all the scenarios it performs better than the other one, right? But you can easily imagine how crisscross could happen here, right? For example, this particular value could be minus 11, minus 111, but the normal value what if the normal value comes out to be 60? And what if the best value comes out to be 141? Which one is more suitable now? Still the first one. Why? Depends on probability is the right answer. You cannot say which one is more suitable now. Now this is more comparable. You cannot make a judgment easily. right? What if the worst case scenario probability is just 0.1%, but the best case scenarios and the normal scenarios probability is, let's say, 50% and 40%, then more weightage is given to the normal expectation and the best expectation. Then why punish your alternative one for just 0.1 chance, right? So it depends on the probability. Then the answer will actually be depending on the chance of each of these scenarios. Okay, but you get an idea. 9 calculation, here's only 6 calculation. You can easily see how it will grow very fast. Alright, so yeah, it basically, it's quite a powerful tool, very commonly used because the scenarios have to be designed very carefully. Here I have given you a worst case, best case in a very simplistic manner, but the real effort goes into defining the scenarios, and there you have to involve many stakeholders. Whoever is likely to be affected by this decision should be part of conceptualizing the scenarios, and once they do, they will have a more more trust on the result that is coming out of the scenario analysis as well, right? So it enables the decision makers to make the decision and identify the insensitive variables and all, but the real challenge lying in identifying the scenarios, right? Mathematical complexity you can easily handle now. There is not so much problem because of so many tools that are available, right? But as I mentioned, so far in scenario analysis, it is a non-probabilistic method. Just the scenario analysis is a non-probabilistic method. It can lead to inconclusive decisions or unconclusive decisions. I don't know which one is the correct one, but basically you are not likely to get 100%. You will be able to make a decision just based on the scenario analysis. You need the information about the likelihood or the probability of each of these scenarios, right? So yeah, because of the human needs to define the scenario, there can always be subjectivity, right? So even though we are talking about mathematics, even though we are dealing with objective numbers, the way you define scenario itself is subjective. So finance is actually not a very objective field in general, and that is something which I will start showing you examples now onwards. The financial mathematics is simple, but how to interpret the mathematics and how to take a decision on that mathematics is very subjective. It's not as objectively defined possible, and everyone will make different decisions based on the same analysis that you will give to them. So mathematics remains the same, but the decision to it is quite subjective. I don't think any field is as complex as here. And you can imagine in a share market kind of a situation, millions of users are interpreting these decisions, information in a different manner. So collectively, how do they behave is also something very interesting that becomes quite challenging to comprehend in a simple course like this. Okay, but the idea, hope you got it. So this is where I will leave you today. Just give me 2 minutes to briefly introduce the concept. As I told, that scenario analysis is powerful, but it requires a probability based estimation. So this is where I'll start showing you examples of how to integrate that probability value into this kind of an analysis, right? I will leave you with this term, the risk and the uncertainty. In general, these are different, or fundamentally these are different concepts. Risk is something that you can estimate. You have some idea, some estimation of the probability that, okay, based on some past experiences or whatever, you can define that there is a 20% chance that this will be the outcome. There is an 80% chance that this will be the outcome. That is how you define the risk. You have some idea to estimate the probability. Uncertainty, by default, you cannot estimate, right? Uncertainty by default is something which there is no way for you to determine it beforehand. But fundamentally these are different, but in this course we'll be dealing with them in a more uniform manner, basically interchangeable terms, risk and uncertainty, meaning you have to do something with the probability associated with it, right? But don't tell it outside anyone that uncertainty and risk are same thing. These are two fundamentally different things. Uncertainty cannot be easily estimated or cannot be quantified, but risk you can quantify based on whatever previous information or the knowledge about the system you have, right? So there are two or more observable values of a variable, and it's possible to estimate the chance that each of these values may occur. The risk is present. Basically, let's say if I toss a coin, if an unbiased coin, the probability of getting heads and tails both is equal to 0.5. This this is a risk-based method. Uncertainty is where there are two or more variables observable, but the chances of their occurring cannot be estimated, or no one is willing to assign the chances. That could also be a possibility, right? What were the chances that a COVID-19 would occur? No one in the industry was willing to assign such kind of a number. Even now that COVID has passed, do you know the probability of occurring a next COVID? No, right? You have no precise information about this. No insurance company is still giving you that kind of a premium. Nobody will say that, okay, in another 10 years, there will be another COVID wave and therefore this is the insurance plan for you. So much difficult to quantify. Those are the kind of things that you deal with uncertainty. But yeah, just for simplicity, here we will be taking them interchangeably. And typically, I'll be giving you such kind of information about something called a probability distributions. And this is where we'll start tomorrow. Okay.